and so we already know what our rotated array is, and now we have to search the element whether it is there or not. Okay, so suppose this is the array given and we have to find suppose target is 1. Okay, now the point is anytime we find a mid, okay, if this guy is a mid, suppose initially, then one half is strictly increasing and the other half decreases. Okay, other half you received increases first 6 1, right? So it decreases and then it increases like that. Suppose if this is the pivot, then again it is increasing in the second half, and then again some random increase decreases, okay, like in the other half. Or if it is in perfectly the pivot position, then it will be increasing in both half. Okay, now what we will do is we'll try to figure out a mid. Okay, we'll try to figure out a mid. Now suppose in this case we found the mid. Okay, this is the mid guy and this is the target, right? So now if target is greater than left and less than mid, then we know we have to move the right to mid -1. Okay, and if not, then we can simply move the left to mid +1. Okay, similarly here also we have to figure out which portion is sorted, right? If it belongs to the sorted portion every time, and so then simply we have to do a mid -1. Okay, so let's try to code the solution. We will understand it more while coding. So now we have a left pointer at 0. Okay, let's have a right pointer at nums dot length -1. Okay, now while left is less than equal to right, const mid equal to, let's find the mid element, math dot floor right plus left by 2. Okay, and first thing is let's check whether nums of mid is what we want. If this is what we want, return return the mid. Okay, else if what we have to do is we have to check what we will check which portion are we in. Okay, so we'll say okay, if nums of mid is greater than equal to nums of left, okay, then this means we are in left sorted portion. Okay, and now else okay, this will mean we are in right sorted portion. Okay, so if we found the mid and mid belongs to the left sorted portion, so either of the time only one will run. Okay, we figure out the sorted portion. Okay, now we found the correctly increasing portion. Then what we have to do, if we are in the left portion, we will check that okay, if in that sorted portion whether our element belongs or not. Okay, so if target is greater than equal to nums of left and target is less than nums of mid, it cannot be equal to because equal condition is checked here. So now basically we found our guy in the perfectly sorted area, right? So we can say okay, we can close the distance. So right will become mid -1. Okay, mid -1. But if we don't find it in the sorted area, okay, that is it doesn't belongs to the sorted area, then we know definitely it belongs to the unsorted area. So left equal to mid plus 1. Similarly, now we are in the right sorted portion. We will say, okay, if target now should be greater than nums of mid, if we're in the right area, right? And sorry, target should be less than equal to nums of right. So this guy means in the right sorted area we find the element. If we find the element, we can close the interval. Okay, we can make the interval a bit closer, or else then it means that the right area is sorted but the element is not in the sorted area. So go and do right mid minus 1. Okay, and now when this is done, let's return a minus 1 here, because if this doesn't runs anytime, then we have to return a minus 1. Okay, some mistake we have done. Let's see. So 0 minus 1. Okay, while left is less than r, we did a math floor, right plus left by 2, nums mid target, we have returned mid. Okay, this is correct. Now if nums of mid, okay, sorry, if nums of mid is greater than, right, then this means that we are in the left sorted area, right, because left is lower and mid is higher. Then we find, okay, whether it belongs to the sorted portion. If yes, then do this, otherwise do that. Let's run it again. Submit.